So a few lectures ago, we saw how we identify which ports are scanned. Now in Input Management, we'll see how we identify which systems are scanned. Okay, go to Kali and open a terminal window. First, I'll prepare an Nmap query, and because I'll play with the destination IPs, it will be the last parameter of my query. Nmap is the command itself. N to close the name resolution, uppercase PN to close ping, uppercase S for SYN-scan. Now to keep it simple, let's scan just the top 3 ports. Now is the time to identify the destination systems. Up to now, we learned to scan a single IP, and we learned how to scan an entire C block, .0 through 24. Okay, so what are the other ways of identifying target systems? You can select a range of any part of the IP address. In the slide, the third and the fourth parts of the IP address is given as ranges. That means Nmap will scan IPs from 192.168.1.0 to 192.168.255.255. I'd like to keep the range small. I'll only define a range for the fourth part of the destination address from 100 to 150. There's only one machine between 172.16.99.100 and 172.16.99.150. You can scan more than one IP block in a single query. The example in the slide scans 2 ranges. The first range is between 192.168.1.0 and 192.168.1.255. And the second range is between 10.0.0.0 and 10.0.255.255. Since I don't have a second network on my Kali, I continue with the third example. The third example is the combination of defining a range and a single number. For example, you can scan the IPs between 100 and 140, IP 206, and the IPs between 220 and 230. So here are the results. Nmap found a machine from the range of 100 through 140, the machine with IP 206, and another machine from the range of 220 through 230. Another way to define the target systems is to give Nmap the IP addresses in a file. In a typical penetration test or ethical hacking, you will scan the network a lot of times. First, you find the hosts. It doesn't make sense to scan the entire network again and again. You'll see huge networks, so if you scan the entire network each time, the pen test will take a lot longer than you think. Let's open a second terminal screen and find the hosts of our IP block using PingScan. As we learned before, now clarify the output to have only the IP addresses of live hosts. Grep command to get only the rows containing IP addresses, and cut command to get only the IP addresses from a row. Now we can redirect the output into a text file to reuse the list in following queries. But first, let me close the name resolution. Now, put a greater than character and give a file name to write the result, iplist.txt. We're not interested in the first 2 IP addresses, so let's edit the file and delete them. I use Nano Text Editor to edit the file. In Nano, use Ctrl-K to delete a line. Use Ctrl-X to exit Nano, press Y to save changes, and hit Enter to save on the same file. Type cat iplist.txt to look at the file again. Now we have 4 IP addresses in the file. Let's create a new Nmap query, and this time, let's give the destination systems in a file, iplist.txt. And here are the results of the 4 systems which are listed in the iplist.txt file. So let's talk about the output management in Nmap now. Up to now, we've run a lot of Nmap queries and got the results on the terminal screen. This is the default output behavior called interactive output. and it is sent to standard output, std out. In a penetration test, we should save the results of the queries to be able to analyze them later on. Hopefully, Nmap has its own output management skills. So let's have a look. There are three major output saving formats in Nmap. Normal output, which is similar to interactive output. That's what you see on the screen up to now, except that it displays less runtime information and warning, since it is expected to be analyzed after the scan completes rather than interactively. Grepable output, which includes most information for a target host on a single line, so you can use it to collect the information you want using the excellent grep command. We've already seen a few examples of grep command in this course. XML output is one of the most important output types, as it can be converted to HTML easily parsed by programs such as Nmap graphical user interfaces or imported into databases. There is one more magic parameter, which is O_A, to let you generate the outputs in all formats. Now let's see the Nmap output management in action. Go to Kali and open a terminal screen. Prepare an Nmap query. For this example, I want to prepare a SYN scan. Now we're ready for output management options. First, I want to generate the XML output using O_X parameter. O_X parameter needs the output file name. You can give the file name with the full path. If you don't specify a path, just as in this example, the file is created in the current folder. Be careful. OX, OG, and ON parameters require the full file name. So if you want the file to have an extension such as .xml, you should specify it here. Hit Enter to run the command. To see the generated file, here it is. And use the less command to see the content of the file. So it's a typical XML file with tags. Here's a host tag, starts and ends. All the results about a host is listed between the start tag and the end tag. IP address, scan ports, and of course, the scan results. Here is another host tag and the scan results of the second host as well. Press Q to quit, less command. Now let's call back our Nmap query with the up-down arrow keys of the keyboard. Now I want to generate all types of outputs. Type O_A and the base name of the files. Be careful, O_A parameter requires the base file name of the files, not the full names of the files, and it'll put the file extensions itself. Let's look at the content of .nmap file using the less Linux command. This is almost the same as you'll see on the screen. Now let's look at the grepable output. Here there are two lines for each host, one to show the status of the host and another one to show the port scan results.